Hello, everyone. Welcome to TestCon Europe's Brown Track. I'm James Apple, your moderator for the Brown Track for the day. Our first talk for the track is going to be by Nikolaj Tolkačiov. He is a testing practice lead at DevBridge Lithuania. It's not his first talk at TestCon. He's been here before. Today, he's going to be talking about continuous deployment, why it's important, dispel some myths that we probably all hold, I hold, about it, the importance of automation and testing in getting to a state where your organization can actually do continuous deployments, and how, hopefully, we can all get there by the end of this talk, maybe even me. He's not here with us today. He is with us in spirit, however. It's a pre-recorded talk, so the Q&A won't work. You'll be able to submit questions to his email only. So I'll post that in the public chat right now. And if you have any questions for him, hit him up via that link, or you can click on his speaker page, go to his LinkedIn. Anyway, that's all, and we'll start the talk now.
Oh, hi there. So today we're going to be talking about continuous deployment. And as this name of this presentation implies, it's a call to arms. Well, if you have a feature, it's done, it's tested, we'll just ship it to production. Easy, right? So this continuous deployment is part of CI/CD, and then CI part is continuous integration, that's clear. But CD might stand one of two things, right? Continuous delivery or continuous deployment. With continuous deployment, as soon as feature is done, it's tested, it goes through a pipeline and goes through all our automated quality gates. If nothing picks up, all of them are green, it goes straight to production. With continuous delivery, that might not be the case, as well, it will go through all the automated quality gates, but it will stop at some point, and then you have this manual step. And it might hide manual regression, UAT, maybe some kind of build verification or release management. A lot of things can hide under that manual step. Even though those two looks really similar, they might be really different. So who is then doing continuous deployment? Like all the builds go straight to production? Well, that's kind of exotic, right? Well, it seems not so. There is a state of DevOps report done by Dara, and they have a very big survey where we ask questions from participants. And well, one of the things they measure is deployment frequency, how often you deploy to production. And if you deploy multiple times per day, then you are a lead performer. If you deploy once per day and once per week, you're a high performer. And once per week and once per month is a medium performer. So if you're deploying every 2 weeks after each sprint, well, you're a medium performer from deployment frequency perspective. And well, what they found out that in 2018, there was already 7% elite performers who are deploying every day. And then there's a few more things you have to consider for this elite performance. They have to have a change failure rate for between 0 and 15%. So they don't fail as much with those deployments. But if they meet those, they are elite performance. And in 2019, that group grew up to 20%, so almost 3 times, and now it's a separate bubble with its own entity. And well, 20% is a lot. For example, if you have 1 in 5 engineers are working on that type of project who are delivering multiple times per day, it doesn't mean it's continuous deployment, but it can deploy multiple times per day without actual manual regression, a lot of like these manual steps and like a lot of overhead. So is it only the bragging rights for being a lead performer? No, it seems that they are twice more likely to meet or exceed organizational goals. Well, if you are that team and you're doing elite, you're deploying multiple times per day, you are more likely to be successful. And well, that's a good thing, right? You want to be that. But there's even more things well, if you have a feature, it's done, it's tested, you can deploy that to production. There is no need to wait for 2 weeks for a sprint to end and some manual stuff happen, and after maybe 3 weeks, you're gonna deploy that to production. You don't need to wait for that. You can do that as soon as feature is ready. So this is great, and well, like this project likes doing that. And another thing is that if you don't need to spend any time with regression and with manual deployments, with code freezing, you spend that extra saved time on actually developing features. So Another thing that from developer perspective, anyone on a team, you know that the things you're working on right now might be in production in a few hours. So you feel, well, you feel responsible of like reducing the negative impact on users, on end users. So you are trying to like think of ways how you can improve the quality, how you can do that safer in order to reduce that negative impact on the end users. And if your users are using any of those systems like Amazon, Netflix, Walmart, or Facebook, those all are continuous deployment projects. They don't have any downtime. They're still developing features as we speak and probably deploying multiple times per day. And they're still working. And because of that continuous deployment, they're so resilient. If they can find a bug, they can fix that without you even noticing, even having a downtime or maintenance window, all of it happening in real time as soon as it possibly can. So this is great, but there is another thing, another aspect from a team perspective. When we work in projects with the sprint deployments, we have some commitment. Like we have a sprint, 2 weeks, for example, and then after 2 weeks, what's done, we're going to be deployed to production. What's all the carryover will have to wait for 2 more weeks to get into production. And because of that, there is some kind of rush. And like you see in this burn down chart, it's actually not fake, it's just displaying that we have problems in our sprints. And it's really hard to go below that blue line. And well, I tried it in few projects, but we never went below. A lot of things have to go right in order for for this to happen. Estimates have to be perfect, your strategy have to be perfect, how you like prioritize things in a sprint so you can finish all of them without actually overtime or anyone idling. So it's really hard, and it's hard to meet that expectation. So what happens then is that we have a code which might be rushed. If you underestimated something, and it's much more complex than you expected, you will start to rush in order to finish that task. If it's the end of a sprint and you have your task unfinished, you will probably rush as well. What happens then is that there might be some bugs which it's not critical. We can live with that. We're gonna put it in another scope. Maybe some features like maybe filtering is not that necessary. We can keep that and maybe implement it in another sprint. So you're not fully finishing tasks just to make it to demo so you can deploy that to production. Another thing which is sacrificed usually is the good practices. They will not help you right now to finish the sprint, so they are not necessary. They're not essential, so they can be sacrificed. Along the way, you will accumulate that technical debt, probably will not have time to actually work on it anymore, but it's just what happens. And then, then that thing, like those rush stories, those user stories, are like tasks reaching the QA column when you need to test them. And well, imagine rushed stories are really not the greatest, and there might be a lot of bugs and might be a lot of testing, retesting, re-verification, lots of things piling up. Maybe like if the developers are idling on that last day before demo, they might start pulling some items from another sprint, just small ones, so they can finish in that specific sprint. So a lot of bad things happening, and you as a test engineer have to prioritize. Am I gonna test everything, or I gonna just keep half of those stories, like test them, and the rest of them will be a carryover? Or I can test everything, but just partially, and hopefully I tested the right parts. Or I can pull overtimes every sprint, just in order not to be a bottleneck. And this is actually an issue. When we start to have a blame game, like who is responsible for that, we look at the QA column. It's full. Like a lot of things are being either like having bugs, and they have to be like tested and fixed in order for us to finish that user story, or that the quality of that things which are reaching the QA column are rushed and they're not quality, like not a good quality. So, and this what happens usually with test engineers by the team. They're called the bottleneck. And like everyone probably know that it's not the thing. Like it's a more complex than just QA as a bottleneck. There's a lot of things going on under the hood. And the thing is that it doesn't matter who is to blame. It all leads to stress. for everyone, for test engineers, for developers, for project managers, maybe even for stakeholders. If they expected some functionality to be there and it's not, because maybe it will take 2 more weeks to finish that, and this is really sad. And I remember, like, I didn't want to be didn't wait for those sprint end, because that's the chaos, and then the chaos starts. And with continuous deployment, that might be fixed. Just imagine, as soon as the story is finished, it's tested, it can go to production. No idling, no lag, no nothing. You, as soon as you finish, it's there. You don't need to wait for 2 more weeks. Then the risk of not making into the sprint is not there. Okay, you might be 1 day late to production, but in any case, it will be much faster than waiting for sprint to end and then after demo deploy that to production. So it's no longer an issue if you're doing continuous deployment. But continuous deployment is kind of hard, and I wish there would be another way how we can quickly fix this chaos at the end of a sprint. Oh, how convenient. New side quest. Let's dig in. So the Kanban is an idea how we can run our sprints later. It's really useful when we're doing continuous deployment, but we can use some parts of that even in scrums or even in sprints. So we can go for apply WIP limit to help mitigate sprint problems. And WIP limit sounds intimidating, right? But it just stands for work in progress limit. So basically what it means that you put this limit on a swim line or a column, like for example, code reviews. You only allow 3 items to be there at the same time. So what happens when you have a lot of code review items, and developers are usually want to work on new items rather than going and code reviewing others? It's not that best time spent, right, for them. It's more exciting to do work on new stuff. So what happens there is that you cannot finish your task if there is already 3 code review items in there. So if you want to finish your task, you need to go and code review something, empty the space, and then finish that task, and then move on to another one. So it just allows you to self-organize the team, and you will not have a bottleneck or piling up or junction of all these code review items. It will only be 3, and as soon as a new item comes in, you will need to go and code review something. And then there is no need to write messages like, hey, can you do code review for me, or anything else. It will be done automatically. You know what worst thing we can do about it? If you see that there's a lot of items in the code review column, we can go and put that to the retro box. Let's write the problem, put it in retro box, and talk about it in a few weeks. And then come out of that retro meeting with 8 items with action points, which we'd never go for. So retro box is a bad way to solving problem. It's a good thing, don't get me wrong, for some of the things, like when we want to appreciate someone or talk about something that's not a problem but you don't like what's happening. But it's not good to actually solving the problem which are occurring during the sprint. It's just not that effective and not that immediate. We can do the same thing for QA column. We can add that limit there. For example, for each of the test engineers, you have 1 item which we're working on, and then extra one waiting in line. But if you have more than that, you can just add the limit and not allow to pile up the stories there. So you will immediately know when during the sprint we have an issue that's possibly we're gonna go and have a bottleneck there. So the team can now organize, do something about it, and help out in order to finish more tasks in there. How it's done is a different story, but it's possible. It's just something that we don't end up with the loss of items. We just don't allow them to pile up, and we solve the problem when it actually happens. And just between me and you, this will not allow any more items to pile up in QA column, and it will not be a bottleneck. So this is great. We finished this user story, at least this side quest of VIP limits, and well, we earned our achievement and trophies. Great. Don't worry, PC gamers, I have something for you. Just so enabling agile with continuous deployment, it's the thing. Like, if we have the power of coming up with requirements, then developing them, testing them, and deploying to production on the same day, this is agile. This is as fast as we can go, and we have no bottlenecks, no lag. We have streamlined how we can get to production, how we can enable or bring business value to the users or the business. So this is great, and this is how we should start going for. So this might enable us to go for full agile, like it's supposed to be. Because if we're not doing that, when we have the sprint deployment, when we develop a task, then do some kind of regression testing for release candidate, then rest of the stuff like verification, maybe some kind of documentation, release artifacts, wherever, and then waiting for that specific window when we can have a maintenance and then release that to production. This is waterfall. This is a small waterfall inside sprint. And that's why we don't like that. That's why it doesn't feel natural. That's why it's not that effective as we were supposed to happen in the during that whole agile, like what sprint's gonna, like what agile's gonna bring us, how fast we're gonna become. So why not everyone is using CD then? Well, I was one of these people on another fence, part of the fence. Well, when I first heard that you can deploy everything was finished straight to production, like, nah, it doesn't make sense. I have confidence in like putting that release to the staging and then maybe marinating it for a week, doing some testing, doing something else, maybe UAT, maybe someone will stumble on a bug. And if we will feel confident that it's good, we can release that to production. Only then we release that to production. But now I understand that maybe that's not the best, most effective way to do that. And there's I can break down this myth. So, for example, let's compare continuous deployment versus classical deployment. And imagine we have an e-commerce site when we're selling items. There's some item price and the tax for each of them, and we have a new user story to update the tax calculation starting from new year, like from next year. There is a new way how we need to calculate taxes, so we need to prepare for that. If we're doing continuous deployment, we're gonna go with one key principle, and it is like database, backend, or front-end changes do not go to the same deployment. Well, it sounds like a bit of strange constraint, but it will make sense just in a few more slides. So we're gonna start with the first feature, and well, we can either go with backend, database, or front end. Well, if we go with front end, we can implement that, but we will need to come back to that feature in order to for us to test it that's actually working. So let's start with something in the beginning, like a database. So inside our database, there is the 3 columns, and for each of the item, there is a price and tax. What we can do in order for us to deploy that to production, and the end users wouldn't notice anything, but we will be ready for like backend changes. So yeah, it's just adding a new column. Users will not notice that. They will still see the old tags. It's the same all logic. We're gonna have just this empty space for us to store the new values. So great, we test that, we deploy that to production, done. Second feature, now we can work with the backend. Inside there somewhere is a calculate item price function, and inside there's another function to specifically calculate item tax. So what we can do, we can copy paste that and change it into something that we need, with the new requirements, how tax should be calculated, and we're adding that to that function. So what happens now is that we test it, we deploy that to production, and users still see the old tags. It haven't been changed. We didn't add any ifs, nothing. It's just a new function where we start to calculate new value. But this, where's the warning here? Like, we're doubling the effort how to calculate this, and this might be taxing our environments. So we need to make sure that this new workload, or like extra workload, will be handled without user performance drop. So what we can do, so we can deploy that to production, maybe add new nodes, maybe move up the tier for our like environments, and then just make sure that we're ready for this new performance load. So what happens now is that it's running in production. No users are actually experiencing anything, but we are calculating new tags for all the items in production on live data. This is actual data, how users are using it. Maybe there's some cancel orders, maybe there's refurbishments, maybe there's something else like returns and maybe discounts. All of those things are gonna be tested and calculated by the users. It's like a involuntary beta testing. And from testing perspective, that data, that results are the gold. You can't get anything better than that. You might make up some kind of mock data, what you expect users to buy, to sell, maybe to purchase and return, but it will be a mock assumptions. It might not represent the actual data in production. So we can keep that build for a few weeks and then test everything, make sure that the data is right. Only we can see from a database if it's okay and there's no issues and there's no edge cases. And then we can move on to with the front end changes. And with the front end, well, we need to add something like this new tax and new total and hide it under feature toggles. And this is something like a permission. So all the users of the system cannot see that. They don't have a permission to see new tags, but the developers and maybe admins and test engineers can see this new tags. So we can go to production and just have an extra testing layer there. So then we deploy it, test that, deploy that to production. So what happens now is that we're ready for that change. During New Year's Eve, we don't need to deploy anything. We just need to run the script to change that permission so everyone will start seeing a new tags instead of the old one. And that's it. So the good thing is that all of these steps, we had to force ourselves to partially deploy unfinished features. And that made us to think how we can do that in a safer way. And we end up with the idea like we have the old tax still calculated and a new tax calculated. So at any point we can roll back, like change the permissions, and then all tax will be shown. We don't have any data loss. Everything is calculated. We can roll back or maybe change something like recalculate new tax from the old one. So a lot of things, a lot of possibilities are there, and we are safe to choose any of them if something goes not as according to plan. So after a while, when we're ready, like when we're happy with all these things, so we just clean up everything what we like had the new UI. Maybe if you delete that feature toggles, maybe remove that old tax calculate function and also the database column. So it just seems like a safer approach. That's why this this principle to constraint for not releasing everything together, that's why it's in place to make it more happen and work for continuous deployment. So let's go to a classical deployment one. So the same story, the same product, but we go with the big bang because we'll need to finish the whole functionality before we can release that to production. So we recalculate the tax. We then change the original tax formula to make sure that we are calculating a new tax. Well, probably in UI we don't need any changes because, well, they're just using a tax from database. So what happens now is that we need to create that, test it, and then put it into some kind of branch, and then wait for New Year's Eve, and then merge latest master to that branch, and then deploy that to production. Someone needs to stay up late and then have a smoke test just to make sure that everything working expected. So what can go wrong, right? So first thing, it will be the first time it touching the production, your code. So all the assumptions, all the mock data, all the old backups you used to test this will be just an assumptions. It's not, it will be still first time that's touching the actual user data. So this might be kind of a problem when we need to have it tested that enough. We don't have anything to contribute to that assumption. We need to make sure that we are actually tested everything. We cannot deploy that to production and make sure that users are testing that and just looking at the data, because they will start seeing this new tags, and we cannot allow that. So another thing is that if you have made this as a separate branch, then something else changing during the sprint, during the New Year's, up to the New Year's, and that might affected our thing. Maybe some UI changes, maybe backend changes, maybe database changes. A lot of things might happen which might affect our results, and they will be different than we expected during that testing period. And maybe if we're releasing with another, putting it in some kind of regression, like release with a bunch of other features, that might affect as well. Even if we are really great and tested everything, developed it as expected, but something else from the same release is not working as expected, you will need to roll back or maybe hotfix it, and that might lead to corrupted data. Like, we have recalculated all the taxes, we might not be able to go back and reverse engineer those. So it might lead to some unexpected results. And then someone needs to stay past midnight to actually deploy that to production, to test it. If something goes wrong, that person might need to go and search for someone else to help him out and who have knowledge about maybe functionality, maybe something else. So it's doesn't seem that safe anymore. Like if you boil it down to all these details, it's like with continuous deployment, you're forced to play it safe. At any stage, you can go back and without users being affected that much. So it just doesn't look from the beginning, but it's more safer. So I hope this sold you the idea. So how can we start move towards continuous deployment? Well, you have to identify the constraint. Maybe it's manual regression. If you have manual regression, you cannot do continuous deployment. If you have some kind of release management, if your infrastructure doesn't support live deployments, maybe something from you don't have feature toggles, you can't hide these features and develop features. You'll need to identify the constraint, then remove them and go for the next one. And this is great because this is continuous improvement. If you get into the mode like you're questioning everything you do, what's the constraints are, how can you move faster, better, more effective, it's just a better way for the whole team and individuals to be working in. And then if after 5 years, continuous deployment might not be the hot thing anymore, you will still be able to steer towards something new because you're always looking for something to improve and you will be ahead of the curve, maybe faster there to arrive at that new goal. So this all stands on key pillars. First one is infrastructure. You have to support live deployments. If you have peak times, if someone is using the system and you have a build ready, you have to deploy that to production. So your system have to support that. And one of the ways is the blue-green deployments. When you have both versions running, a new one and an old one, and you just ask load balancer to just switch to an all new request to the new version. And this is just solves the problem how you can go without any maintenance. There's more things in architecture side, but let's leave it as simple as that. You can do the canary releases. It's something like the mobile applications we're using. It release new version of application just to part of the users, like 5%, maybe beta testers, maybe just random people, and they start using the new version. If they see a spike in like errors or performance issues or users start complaining, they will stop the release and just roll back for those people who are like experiencing those issues. But rest of the 95% will not notice anything. So this can be done with the load balancer as well automatically. If you see a spike in performance or errors in 500 and server errors, you just like remove all this new requests and just move them to the new to the old version, and that's it. That new version will not be accessible anymore, and you can fix those issues and then try again. This brings to reliability. If you have continuous deployment, you have to have a reliable system, but it will not only benefit this continuous deployment idea, but your users as well. They will always have working system. There is some fail checks and how you can just avoid like blackouts or like maintenance windows. We can always use the system and it will be reliable. If there is a bug, if there's issues in production, you don't need to go for extra maintenance window just to deploy the new version. You can just deploy it when it's available. And you need to have a good grasp of what's happening in your system. So monitoring have to be in place. If you deploy so often, you need to measure if there's errors, maybe there's some user problems before they actually report you to that. Maybe you're already working on solution, then they report to that, and in 5 or maybe in an hour, you will have that deployed to production. So ahead of the time for like faster feedback cycle is a key here. And then we go to the automated quality gates. So imagine you have a build, it's developed, like you have a feature user story, it's done, you test that and you deploy that to specific pipeline, and then it goes through all of the quality gates. If they're green, it goes to production. So you have to trust that. You have to make sure that if it's green, that means there is no major issues and I can deploy that to production. You have to tinker it as much so you can trust that and it wouldn't affect users. Like users wouldn't pay the price of being frustrated by you doing continuous deployment. So that error rate have to be around 5% in order for you to be successful on continuous deployment. So only after like 20 deployments, one might have an issue when you have to hotfix something. And another thing is that from software perspective, like architecture have to support live deployments, maybe multiple versions running in production, like application versions running in production simultaneously. All of that have to be supported. Feature toggles is a must, and how you develop features like these limitations, like only one thing you can work on, like database backend or front end changes. those have to be also embedded in this how we develop the software. So all of these three pillars are actually required to get there to continuous deployment successfully. If only one of them want to do that, the rest of them not, it will not happen. You will not force everyone to do that. So all of them have to work together in order to achieve those results. This is how we actually trying to move that in our organization. So we're doing cross-competence training. So developers, test engineers, DevOps engineers, they all have cross-competence trainings where we share our knowledge, showing us the back behind the scenes, how we do working, what are the constraints, how we are like all our tricks, tips and tricks. We share that knowledge. It's more visible, it's more understandable. We can easily collaborate and help each other in those processes. And that's how we grow as individuals, as a company, and then might be one day going for a fully continuous deployment for all our projects. Then we have metrics where we showcase what we think it's important, and some of them are from same as like this book of Accelerate, where we have this four key metrics. One of them is deployment frequency, how often we deploy. So this is a green, like more often we deploy, the better it is. And then the rest of them, we have some custom ones, but like this change failure percentage is something that we care about as well. We ranked this one up to 11, and like not only hot fixes and rollbacks were calculated in that, anything what escapes our quality gates is registered there. So that's why this one is pretty high. So we a little bit overdone it, but yeah, it was an experiment, so we learned from that. And this one have to keep between 0 and 15% if you want to have continuous deployment. If you're deploying less often, that's fine. So as you can see here, we already have few projects, because this is like actual data from the beginning of this year, where we have two projects which are deploying every day, and one of them is deploying every second day. And as you can see, the failure percentage of those are quite low. So you have to keep in mind that if you have the same project, same team, but one of them deploying once per week, and they have one bug, it will be 100% failure rate. And one is deploying every day, but they have the same one bug, it will be only 10%. So these numbers have to be taken together and not like in separate. So, but still, it shows that those projects who are deploying every day don't have that failure rate as big as we expect. It's like 2% means that once per 2 months, when you deploy every day, you have some escape defect. And that's great. This is the speed we want to be. And like, we don't have any regression. The team is more effective. They're working on features, like deployments are almost automatic. In all of those cases, it's not continuous deployment. It's it's just like continuous, like continuous delivery, and there's some like downtime, and it only happens like during maintenance windows, so these deployments, but it's not that far away. Another thing is that investment have to be there from management perspective. They are improving these changes. They cannot drive that, they cannot make this happen, but they have to allow team to experiment, because all boils down to actually following this idea of DevOps, like automating everything what can be automated. If you have manual effort where people just doing manual step-by-step things and they can be automated, that should be automated, because well, we're wasting human effort, which we might do something more useful rather than follow the instruction how you can deploy that to production. Doing manual regression step by step, following the test cases, it's just redundant. And if we can reduce that, we can save not only like for people to be more happy to work on a project, but we can save some money, because there's manual deployments. If you deploy every sprint, it have a cost. It have a huge cost at the end, maybe at sprint 100, maybe it's not a cost at sprint 0 or sprint 1. And just the same team, if they don't solve this manual deployments and all this technical debt, we will start slowing down at after each of the sprint. That scope gonna be increasing, and you will work more and more just to finish the same things. And just the cost of that, we don't usually calculate that, but we just see that the team don't develop as much features as they used to be. This is the reason. And this manual deployments, it's a cost. It's not an investment. You pay it for you to be able to release a production after 2 weeks. It's no longer any value of it to you. So it's a redundant cost which you can actually save. And this is just what I like about continuous deployment. If we're doing that, there is no gray area. Either you have everything automated or you're not. So with continuous delivery, you can, that's like 50 shades of gray. Like there's a lot of things that can happen and it's still continuous delivery. So let's move on to the summary and let's go through the list what we covered today. So first thing is that trends are showing that CD is not going away. It's keep growing, and we don't have any data for 2020 and 2021. Well, it's usually posted on September, so it might come out soon. So that percentage might have grown to 25%, 33, or maybe stayed at 20, or maybe even lower right now. But it's still, it shows that it's not like it's not a flux. It's a thing that everyone is trying to go for, and big companies are implementing that, small companies are implementing that, startups are implementing that. So it's viable and something that we have to consider once more if we passed it before. Because if your users are using those systems, they're used to that. They have some kind of like idea what paid services or even free services, how they look like. And if they see that you're not delivering and there's some startup who can deliver that like seamless experience with you, it's always working, features are being deployed, but you don't see them like happening. You just see their features being available to you. So from user perspective, that's how paid services, I mean, free services should look like. This is a new thing. This is a new standard. And then if you want to get there to continuous deployment, you have to deploy each completed feature automatically to production, and you have to keep that fail percentage between 0 and 5%. Anything above that, well, you will just create more frustration for your users, and they will be just experiencing, oh, it's not working again. And maybe that will happen multiple times per day with different bugs, and just not the experience you want to put your users through. Like continuous deployment is great. They have to benefit that, not frustrate the users. So you can get there by doing continuous improvement, like choose what most painful or most gainful constraints and just well, remove them, and then go for another one. And always try to improve your process, your project, and you will be going in the right direction. Your team will be happy, will learning something, and will be improving, and they will feel that, and will see the results of that. And then this transformation have to be driven by engineers. Management can enable that, they can ask for it, but if engineers don't believe that, if they don't go there, we will find hundreds of reasons, and then they fail to implement continuous deployment. They said, well, we said we can't do that, it's impossible. So it have to be started engineering, they have to be willing and skillful enough to actually go and completely finish that transformation. So another thing, and last thing, if you're not doing continuous deployment, you might be already late. You might not be elite. You might not be even the high performer. You might be a medium one. So you have to think about it and maybe just decide to go for it, because it seems that it's not going away. It seems like it's a new normal. And this is like part of DevOps, like improving, automating everything, and just working towards like more cohesive project, how you can run this and be more successful in your business. And this is the key here. And well, I hope this presentation actually made you think twice, maybe gave you some ideas how you can improve or go towards that. So thank you. This session is pre-recorded, so unfortunately you can't ask questions afterwards. Maybe I'm there, so who knows. But basically, you can contact me via LinkedIn, and we can continue this chat, and then I can answer your questions. And let's go there together. Like this continuous deployment seems like a fun thing for everyone. So yeah, good luck to you on journey, and have a great rest of the conference. Bye.